Hello all, welcome to the episode 1C in hexadecimal of Debugging TV Frames program. The topic of today's episode is analysis of memory dumps from Windows 8.1. We briefly analyze process, kernel and complete memory dumps. We also look at some File Explorer threads and see what's new in Windows 8. So first we analyze the complete memory dump. We all know that the so-called local security authority subsystem may contain some security information, and recently there were some WinDbg extensions released that allow you to dump password hashes and so on. And so we decided to save a complete memory dump without this process. So what we did, we killed this subsystem in running Windows 8.1. Then a message box appeared saying that the system would be restarted in a minute. And in the meantime, during that minute, we triggered a complete memory dump using Not My Fault tool from sysinternals. And so the result was a complete memory dump saved. So now we open WinDbg, the latest one, and then we open a crash dump. I open log file. And we fix symbols. You reload. And now let's look at the short list of Windows processes using bund process command 0 and 0. Also notice that handle count feature a bug in the latest versions of WinDbg. This feature wasn't fixed. You see that handle count data not accessible, not fixed in the latest version of WinDbg, and it was still present in the previous one released with Windows 8. It works for all dumps before Windows 8, but with Windows 8 memory dumps it is not able to show handle count. But anyway, we search for LSASS and find this process is actually a zombie process. Handle count is 0. And if we look at this process, so we see no threads. So indeed this process was killed. And we actually got a complete memory dump which has all processes except this security sensitive process. So this is what I wanted to show you. Complete memory dump analysis without this process, local security authority subsystem process. And now I show you another Okay, there is a question. Let me see. I'm not sure why a phone isn't working. Do you hear me over microphone? Let me see the settings. No, the audio should work. I don't know. In case you can't hear anything, then I'm sorry. Maybe there is some glitch. Please later on check the video of this episode. Maybe you will be able. But what I think that audio through microphone, through speakers, through voice should work. Through microphone and speakers, it should work. Okay, I see that you hear computer audio. So, okay, let's continue then. So the next memory dump analysis exercise that we do is look at the so-called Fibre Bundle memory dumps. Let's see picture. So here's a graphical representation of this idea. The concept of Fibre Bundle spaces was taken from mathematics. You have a base space, here kernel space, to which are attached various fibers, fiber spaces, similar to a comb. Here fibers are various process memory dumps, and this might be helpful when you have so much memory that it's impractical to send complete memory dump, or you don't want to send complete memory dump due to some security reasons. So in this case you can save memory dumps from some processes you suspect and then force the kernel memory dump. So we did for internet. So we did that for File Explorer, and now we open another instance of WinDbg and open a crash dump. So this is what the dump we are going to open. That was File Explorer showing some error. So we open a log file. Then we fix symbols. To reload. And now we list thread stack traces. And suppose we are interested in this error box. most likely this is this user space stack trace showing a dialog box. So let's now open a corresponding kernel memory dump and see stack trace, kernel stack trace portion of this thread stack trace. So we open another instance of WinDbg and this is kernel memory dump. So we open a log file. I post all these log files later on. And we dump the list of processes and look for Explorer process. I think we missed one. Yes, this one. So we take this address and then we dump this process stack traces, kernel space. We use 3F, no, but it's okay not to use flags actually, but let's use 3F. So there are many threads, but in the meantime we switch to our user dump and notice this thread ID, and then we just 1 second it finishes, and then we search for this thread ID in the output. Actually, to find out, we prepend 0 and add dot. So we found kernel mode, kernel space portion of this thread. This is just a thread that is waiting for multiple objects, and if we go back, we see that the corresponding user space is also waiting for multiple objects. One thing I also wanted to show you is, if we go back to user space, we actually find out threads. If we search from the end, we find out threads which are actually suspended, and stack trace seems to be just one thread, user thread start call. So if we switch to this thread, let's, for example, we set it the current, we see the stack trace is just one line, and if we dump this raw stack, if we dump stack segment, for example using DPS, we find out that it is all zeros actually, except then maybe this address, but it is all zeros. And if you find this, so let's see, this thread ID is this one, 63C. So if we go back to kernel dump and search for this thread, we find out that this is actually in kernel specified, and this is suspended thread, and seems to be it just started and was suspended. So seems to be there are some threads in File Explorer that are started in suspended mode, and I found that these threads appear actually when we copy files, copy or move files in File Explorer. For example, I did experiment. So actually on this slide I also put these 0 threads, what I call them. They are called 0 threads, just an analogy with 0 pages. And so I did experiment. I launched, so let's open a new instance of WinDbg. I launched File Explorer. This File Explorer got this dump. There were no such 0 threads. Then I launched the second copy, and actually in Windows 8, at least in 8.1, but I think in 8 as well, I have to test all File Explorer windows, they belong to the same process. So I launched the second window of File Explorer, saved the process, and there were no 0 threads there. But then I closed the second window of File Explorer and dumped, still no 0 threads. Then I opened again, and then I started copying files and got saved this dump. So let's open it. This file, this dump actually was taken when we tried to copy 3 or 4, I think 4 files simultaneously, one after another. They were added to the same dialog. And actually, let's open log file. Fix symbols. And if we dump stack traces, we actually see some stack traces that are doing copying files. They use this copy file to function, which allows you to provide notification function. And we see one thread doing copy file, the second one, and also notice the appearance of these 0 threads. Then we start copy, and then there is another copy file operation, another. So basically, I remember now we tried to copy 4 files, one after another. Not 4 at once, but we tried to copy, launch the first copy, then we launched the second, and so on. So we have different threads now in one process doing copy files. And you know, in Windows 8 there's nice graphical representation of copy with such histograms, with some histograms. So, and this comes at a price, because now we get CPU spike in thread, but which is actually normal because we are just doing file copy. but file copy is done with notification with nice graphics. You see this GDI plus. So what we do now, let's find this thread. Obviously it will be consuming CPU. So we use runaway command, and we see that there is such thread indeed, 49, consumed 7 seconds. But if we close this dump and open another one, after some time, when copy was still going on, I saved another crash dump, and now if we type runaway, we see now this is another thread. Actually the number changed, it is 44, but this is one EC, so let's open this log file just for a second to check what was thread ID. So the number is different because some threads were added, some removed, but still thread ID is the same. So we see that it's clearly spike, increased. So and it is now 22nd. So let's switch to this thread and check its stack trace. So we see it is doing some polylines using GDI plus, finally calling GDI functions. So this is what I wanted to show you. And the last what we see, if we look at this, if we look at stack traces, again, let's dump them. Way around. We dump stack traces in File Explorer from Windows 8.1. We see the presence of this long C++ template style function calls or symbols. This is because the new File Explorer in Windows 8 uses Windows runtime library. Originally I thought this runtime library is unique to Windows 8.1 version because, for example, you see this module. If we dump its symbol, we see lots of template style function calls. But if we open the same Explorer crash dump from Windows 8.0, so for example what I'm going to do, so I quit this dump and then we open another crash dump, but now with Windows 8, and if we dump stack traces, we see that it still uses the same module like SH core, but there are no such C++ template style function names or symbols, but if we dump this module symbols, we see the same Windows runtime library names, symbol names. And so we found out that the presence of such names on stack traces is pure coincidence. So if we quit and then reload the crash dump from Windows 8.1, Explorer, for example, let's load again, 6.1, and dump stack traces. Let's, for example, go to the one of the first, such as this one. See, the presence of this symbol is just pure coincidence. For example, if we take the return address of the next function and disassemble it, we see so we just think that this is just a coincidence because the symbol, the address just happens to correspond to this symbolic name as the nearest symbol. For example, one of them is different one. And for example, if we disassemble, actually as this address as the whole function, we get some meaningless results. For example, we see all these template definitions, but what we also see get message loop. Go and get message, translate message, dispatch message, but the symbolic addresses correspond C++ template like. Maybe this is not coincidence, but for me it looks like a symbolic coincidence. So this probably clutters understanding of disassembling. So this is what I wanted to show you, and here's example. I also don't think that File Explorer was significantly rewritten from Windows 8 to Windows 0.1, and the appearance of such symbols is just, I still think this is a coincidence. So this is all, and finally this is the usual add slide of forthcoming training sessions and free webinars. We have the updated advanced Windows memory dump analysis training starting later this week. There are still seats available, and also Deep Down C++ course starting in 2 weeks. And we also plan a free seminar on software forensics in January. Unfortunately, due to very busy schedule, we moved other free seminars to the next year. So hopefully see you next year for these postponed seminars, such as semiotics of debugging and so on. And so, thank you for watching this episode. Please later check out the slides, logs, and recorded video from debugging.tv and YouTube. The next episode should be on the 23rd of December due to advanced Windows memory dump analysis and Deep Down C++ training sessions this month. So thank you very much for attendance, and see you all in 2 weeks. Thank you. Bye-bye.